All right, so what we're going to do in this section is we're going to get away from what we were doing last week, where you're figuring out limits by looking at numbers that are getting closer and closer and closer to the specific value, or even by looking at the graphs and try to figure out ways to calculate limits of functions algebraically, like just by doing math, okay? So that whole thing last week was sort of introduction, so you'd understand the concept of a limit, of, you know, the y value that the graph approaches as it gets closer and closer to a specific point. And now we're just going to kind of get into the nuts and bolts of all this stuff, all right? So today is ridiculously easy, but we kind of have to do it to set up what's going to happen tomorrow. And tomorrow my co-teacher will be presenting you with some, you know, algebraic, mathematical ways of solving these. Okay, so this is really dumb, but we're going to do it anyway. Here we go. So we're going to start with two functions. F of x and g of x. And here's what I'm going to tell you. It is groundbreaking stuff. If you want to figure out what the limit as x approaches a of these two things are added together, guess what you have to do? Add the individual limits together. So that would be equal to the limit of the first function plus the limit of the second function. Astounding stuff, isn't it? I mean, you know, if you want to take a minute to kind of let that sink in, or I don't even know if you need to write this down, but like I said, we need to just kind of establish some of these rules so that all the algebra that we do tomorrow and in the future actually works. If you want to figure out the limit of two functions subtracted, guess what you do? Subtract the two limits. Yes. What an astute bunch of students you are. We pretty much just lost by default. If we're down the shaft, then it's over. Okay, so you can add them together. You can subtract limits from each other. Look at the page. Okay, you could also multiply by a number. So if I wanted to figure out what the limit as x approaches a is of some number c times a function, if I know the limit of the original function, then I just take that answer and multiply it by c. So c in this case stands for, you know, 5 or 12 or negative pi or something like that. And we'll do an example of this in a minute. There's two more. The limit as x approaches a of two functions multiplied together, but you didn't see that coming, is, wait for it, the limit of the first function times the limit of the second. Can we go over that again? Okay, and there's one last one. Any guesses? What the last one will be? Maybe, yeah, something like that. You want to know the limit of two functions divided by each other, then you take the limit of this one divided by the limit of that one. And that has a little kind of thing there. You can't divide by 0, so you can't do this if the limit of the bottom function is 0. Okay? All right? Okay, so let's turn to page 78. And there's a fun little graph there. And let's use the graph and these exciting new rules to solve some limit problems. See the little graph? Come on, Chad.
There.
Okay, so on that graph, the red function is f, and the blue function is g. Okay? All right, so the limit as x approaches 2 of f of x plus 5 times g of x. In order to do this, you first figure out what is the limit as x approaches -2 of f of x. So look at the graph, and the answer is 1. There's a hole there, but the graph gets closer to 1, right? Okay? Plus 5 times, what's the limit as x approaches -2 of g of x? -1. And 1 plus 5 times -1 is -4. Okay? You guys see where I'm getting these individual answers here? The limit as f of x approaches -2 is 1. I'm looking at the graph. Yeah. The limit as x approaches -2 of g of x is -1. We're okay with that? Okay? All right, how about the limit as x approaches 1 of these two things multiplied together? So what's the limit of f of x as x approaches 1? Everybody should say with enthusiasm, confidence, pride, 2. Right? All I have to do is go over to x equals 1, go up to the f of x graph, that's y equals 2. So the answer is 2. What's the limit as x approaches 1 of g of x? What's that? Overall. It says x approaches 1. It doesn't say from the positive or negative. So there is not 1. It does not exist. So our overall answer there doesn't exist. Okay? Since there's a break there, there's two different limits. Does that make sense? Okay? Then it's not going to work out for us. Okay? And then how about the limit as x approaches 2 of f of x divided by g of x? What's the limit as f approaches 2? Got to estimate a little bit there. You're going 1.5er. What's the limit as x approaches 2 of g of x? 0. So what's the answer? Right, can't do it because I can't divide by 0. Okay? Okay, so that is a way that you could do it by looking at the graphs. And so basically, hopefully what you picked up from that is one easy way to find the limit is just plug in the number if you can. Okay, so when we look at the graph, if you go over to x equals 1 and you go up to the graph and the graph y equals 2, then basically what you've done is you've taken x equals 1, plugged it into the function, got 2 as your answer, and so then that's it. Okay, so one way that you can solve limits, what you should always try first is simply plug the number into the function. And if you can't do that, then you're going to have to do some algebra to change the function so that you can, which is what Ms. Fowler is going to work with you on tomorrow. But in this case right here, you can just plug in 5. And by all those limit laws, because I can multiply and all that kind of stuff, my answer is going to be 2 times 5 squared minus 3 times 5 plus 4, which is, what, 39? Well, you looked it up for what?
I did. I did in my head, I swear.
39.
I swear.
Okay, well, it's wrong anyway. It's 41.
Okay, fine.
Okay? Is that like super, are we okay?
39.
Or if I wanted to find the limit as x approaches -2, of this. Come on, Shad.
Come on, you okay?
limit is x approaches -2 of x cubed plus 2x squared minus x over 5 minus 3x. First thing you're going to do, always try and plug in -2, see if it works. -1 over 11.
There's a puzzle. Yeah, it's
-1 over 11 is correct. Okay? And that, what we're doing right here is called the substitution property. Which says that if you want to find the limit of the function, one way you can do it is just by substituting the value in for x as you are. Okay? You all right? Okay? Way too much?
Family thing.